All right, sixth graders, so what we're gonna do today, or sorry, on this video lesson, is actually take our ratio data and information, whether it's from a table, equation, or double line graph, and plot it on the coordinate plane. So essentially, we're gonna take the data and graph it onto an X and Y axis, all right? So that is the goal of this little lesson. All right, so the first thing you have to look at is you got a question. We need a context to do this work. So in this case, we have Kelly traveling with her soccer team from a few cities in, looks like New York to West Virginia. Okay, so you see that the distance is from leaving New York to Morgantown is here. Okay, so here it is. Okay, and then the second table is kind of the reverse, going from Morgantown back to that town in New York called Yonkers. Okay, so in terms of what they're asking us to do, okay, first thing says create a table to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule, assuming that the ratio of the amount of time traveled to the distance traveled is the same for each city. Then extend the table to include the cumulative time it will take to reach each destination on the ride home. Okay, so that again is very wordy. Okay, so what I'm gonna do here is start with maybe the distances, because we can see in the question to the first four towns you get 100, 200 miles, 300 miles, and then 400. And because it says this word cumulative time, it's going to be just kind of adding the time. So that means the distance kind of keeps increasing. So the total distance traveled, we just keep adding it up until we get to 800 here. Okay, because it's 400 miles one way and then 400 the other way. Now, the trick is, what is the time? So we have to kind of look back in the question. What is the time? It says the total trip takes 8 hours right in here. Okay, so that's an important bit of information. Now, is that 8 hours in one direction or is it both ways? And it looks like if we read the question carefully, then the distance it takes to go the first 400 miles is 8 hours. Okay, so this total length here, and I'll write it in, whoops, okay, is 8 hours. Okay, so if we kind of go consistently backwards, we can assume then this idea that it would take 2 hours to go the first 100, 400 to go the 4 hours, sorry, to go the next 100, add another 2 hours to go to 300, and so on and so forth. Okay, and then I'll just add these times in likewise. Okay, so here it is. And so that is the table that we start off with. Okay, now let's keep going. So after we create the ratio table, another thing we can do is represent this information on a double line graph. And that's all it's asking you to do in part 2. So in the double line graph, we just have to remember that we have to kind of label the top part of the graph and the bottom. So I'm going to put on the top here the time, which was in hours. Okay. And then the bottom was distance, which is represented in miles. Okay, or measured in miles. Okay, so at time 0, there's going to be 0 miles traveled, and then we'll kind of work with the table. It was 2, 4, 6, 8, 10, 12, 14, and then 16. All right, and then for the distance traveled, if we recall, the distance is, it was 100 miles for every 2 hours. So then this is going to fill in the second part of my double line graph. Okay, and there we go. So the next part of the question says, using information in the double line graph, how many miles would be traveled in 1 hour? Okay, so again, if we look at the double line graph, and imagine, 1 hour, it divides each section perfectly in half. So this has to be 50. Okay, so the train is going at about 50 miles per hour. So 50 in here. Okay, and how do you know we divided our time section in half, which marks half the distance? Okay, and that's kind of what we did with the double line graph. Okay, now the example kind of carries forth, because this is what we're trying to do now, or this lesson is trying to do, is to tell you, well, how do you go from these tables and double line graphs to actually drawing this on a coordinate grid like so? Okay, so what you have to do next then is kind of imagine what to do with this graph and this table. Okay, so recall in the coordinate grid, you have the x-axis and you have a y-axis like so. And most times what goes into the information that kind of sits in the x-axis, usually that is a time unit. So I'm going to put x in there. So whatever is in time will be plotted on the x. And then for the other vertical measurement, which is miles in this case, that will be in the y. Okay, so I'm basically going to copy out times and distances just from my double line graph or even my ratio table from previous page. So 2 and 100, 4 and 200, 6 and 300, 8 and 400, 10 and 500. And I'm getting cut off here, but of course I could extend it all the way to 16 if I needed to. And I'll just go to 700 since I'm a little bit short in rows here. Now the next part of this is ordered pairs. What is an ordered pair? Okay, so remember, an ordered pair represents a coordinate point, x comma y. It's basically how we put the points. If I use my pointer on the grid here. Oh, and there's my Luke Skywalker lightsaber. Okay, so anyways, it's basically how we plot on the coordinate grid. So if you don't have ordered pairs, then it's kind of hard to plot on the grid. Okay, so how do we get the ordered pairs? It's basically the information from our ratio table. So the 2 and 100. So we're going to put 2 and 100, 4 and 200, 6 and 300, 8 and 400, 10 and 500, until we do the last one, which is 14 and 700. Okay, now the trick here is, well, in the corner, or what we call the origin, we start at 0. But how do we plot the rest? We actually need to figure out a scale for this. Okay, and so I'm going to draw a scale out on each axis. Okay, so for the sake of time, I just actually put the scale on there. The one important thing when you're doing a scale is you have to try to use a lot of your grid paper. Now in this case, I actually didn't use tons of it, so it's not a great scale, but for the purposes of this graph, I think it's okay. Now you notice the spaces going up the vertical axis, like here, there's spaces. And I actually didn't write every number in here on the bottom. So the reason for that is because the graph becomes very cluttered and messy if you do that. So I know that the first block is 1, so the next block is 2. And that's what I'm doing. I don't recommend that you put in every number. It's just very gross to look at and hard to read in the future. But after you put out your scale, you can actually graph the pairs. So it's the first pair was 2 and 100, so then I find 2 across, and then work up to 100, which happens to be halfway between 0 and 200. The next one was 4 and 200, 6 and 300, 8 and 400, 10, 500, 12 and 600, 14 and 700. And there is, I guess, the plot of my graph. Now the next thing we could do is draw a straight line in here. And do I have a line tool? I thought I had a line tool. I can't find it. Okay, so I have no line tool. So I'm not going to draw a line through this because it's going to be very messy. But typically speaking, afterwards, you would start from the origin and draw a line through all your data points. Now, the nice thing about this is now you can use the graph to find out information that wasn't plotted. So in here, again, I'll use my pointer. I could actually answer questions or problems that talk about points that aren't plotted in there. Sometimes you'll get questions that extend beyond the points. And then you can also use your graph to answer questions in that way. So that's the gist of this lesson. The next 2 pages that you have is just basically doing this. So I skipped it over, but there it is. There's the lesson summary. And then you have a problem that involves sugar and a recipe for pie. Okay, so do that question, and that's going to be your homework. Thanks. Bye. With a different problem. Okay.